So, we're diving into a pretty provocative question today. When we're talking about climate change, what's really more powerful? Is it a new wave of politicians, or is it a new wave software? Well, this explainer is going to dig into the surprising answer. I mean, just think about that for a second. This is the big idea we're exploring. Forget all the grand political gestures just for a moment and think about the quiet, relentless power of code. Is it possible that the most impactful climate solutions aren't happening in parliaments, but in server rooms? And the stakes could not be higher. We are looking at nearly 38 gigatons of energy-related carbon dioxide emissions. That is a staggering, record-breaking number. So any tool that can start to bend this curve, like right now, is absolutely critical. All right, here's how we're going to break this down. First, we'll get into that big question and separate the hype from the actual math. Then, we'll look at some real-world climate wins that AI is already delivering. After that, a much-needed reality check on its own energy footprint. And finally, we'll see how policy and code can and really must work together. Okay, so to even begin to answer our question, we've got to ground this whole conversation in data. Let's take a look at where our emissions are actually coming from so we can understand where a tool like AI can even begin to make a difference. Now, what's really fascinating here is just how concentrated the problem is. Look at that. About 75% of all greenhouse gas emissions are energy-related. We're talking electricity, heat, industry, buildings. These are the physical systems of pipes and wires and machines that run our world. And guess what? Those are exactly the kinds of systems that can be optimized. And this, right here, gets to the absolute heart of the AI advantage. AI doesn't make policy. It can't pass a carbon tax or sign an international treaty. Its power is in execution. It takes the physical world we already have, all those pipes and wires, and just makes it run smarter, squeezing out waste, watt by watt, in real time. Okay, so enough theory. Let's see what this actually looks like in the real world. We're going to walk through 6 specific examples where AI is already delivering measurable results, turning these abstract goals into actual, avoided tons of CO2. And really, where better to start than in the tech industry's own backyard? I'm talking about those massive, energy-hungry data centers that power the internet and AI itself. This number is just a landmark. Google's DeepMind AI was able to cut the energy used for cooling its data centers by a whopping 40%. 40! And it did this by learning the incredibly complex dance between thousands of sensors and controls, and it actually performed better than any set of rules that human engineers could write. And that's the real magic here. The data center was the proof of concept. The exact same principle, using AI to control complex, energy-intensive systems, can be applied almost anywhere. Think about the HVAC in a skyscraper, or the giant kilns used in heavy industry. Speaking of buildings, man, they are the sleeping giant of emissions. And as you can see here, the potential is huge. Just look at that case study from 45 Broadway in New York, nearly 16% savings on their HVAC energy bill. And you want to know the best part? It was a software deployment. No expensive rip-and-replace hardware overhaul, just smarter control that literally pays for itself in a matter of months. Okay, let's talk about the backbone of our whole energy system, the electrical grid. Getting more renewables like wind and solar onto the grid is a massive challenge, mainly because they're intermittent. The wind doesn't always blow, the sun doesn't always shine. This is where AI just changes the game. By using machine learning to more accurately predict wind patterns, Google was able to increase the economic value of its wind power by about 20%. See, better forecasts mean the grid can actually commit to using that clean power ahead of time, which means less need to fire up those fossil fuel backup plants. Now this is one of my favorite examples because it shows this perfect synergy. Methane is an incredibly potent greenhouse gas, and tackling leaks is probably the fastest climate win we have. So a government policy like the new U.S. methane fee creates a really strong financial incentive. But it's the AI that makes it truly executable. AI-powered analytics just comb through satellite data, find the biggest leaks, and let companies send repair crews with surgical precision. They avoid the fees, and often they make money from the gas they just saved. And believe me, the applications do not stop there. In heavy industry, AI is fine-tuning processes like cement manufacturing, which is a huge source of emissions, to cut down on fuel use. And over in the energy markets, it's automating procurement, so a big company can automatically shift its power demand to the times of day when the grid is flush with cheaper, cleaner, renewable energy. So far, I know,
AI looks like a climate superhero. But to give you the complete picture, we have to talk about the elephant in the room: AI's own massive and rapidly growing appetite for electricity.
And here's the central tension, right? Both of these things are true at the same time. AI is an incredibly powerful tool for system-wide efficiency, but the very infrastructure that runs the AI is a major and growing consumer of energy. And the scale of that demand is, well, it's startling. While data centers used about 1.5% of the world's power recently, some projections show they could be eating up to 12% of all electricity in the United States by 2030. What that means is the growth of AI has to be tied to the growth of clean power, period. So this brings us to our final section, and this is where it all comes together. See, it's not a question of AI versus politicians. It's about understanding their distinct and totally complementary roles. This slide just illustrates the division of labor perfectly. Think of it like a sport. The politicians, they set the rules of the game. They create carbon prices, they set efficiency standards. But AI is the elite athlete that actually plays the game, optimizing every single move within those rules to cut waste and score goals. So what does this actually look like in practice? Like right now? This lays out a really concrete roadmap. Utilities can use AI forecasting to stop wasting renewable energy. Building owners can deploy autonomous HVAC for immediate savings. Oil and gas firms can use that AI leak detection to avoid those new methane fees. These are real, actionable steps for the next 24 months, not some far-off futuristic dream. But here's the thing. None of this matters if you can't prove it's actually working. The mantra has to be measure everything. We need hard, verifiable data on kilowatt hours saved and tons of methane avoided. Software solutions demand software-level accountability. And this, right here, is the single biggest takeaway from all of this. Policy without execution is a press release. AI without policy is a pilot. Together, they scale. It is only when you combine these two powerful forces that you get real, meaningful impact. So let's circle all the way back to our initial question. Can AI solve climate change better than politicians? And the answer is, it's the wrong question. AI can't pass a law. It can't build a new transmission line. But what it can do is execute on our climate goals with the speed and a precision that we humans simply cannot match. It's the engine that turns policy into progress at machine speed.